Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 40, and this problem asks us to explain the observed rate of reactivity for the following secondary alkyl halides in an SN1 reaction. So we have an increased reactivity from the left to the right, and what we know is that in an SN1 reaction, you will increase your reactivity by increasing the stability of your intermediate carbocation. So remember, the first thing in SN1 is that your leaving group falls off, so if our leaving group were to fall off in these compounds, we would be left here now with a carbocation here. In this molecule, we'd be left with a secondary carbocation here. And here we would be left with also a carbocation here. So why is it that the stability of these carbocations increase from left to right? So remember, your increased reactivity for SN1 reaction increases with the increased stability of your intermediate carbocation. So let's look at the very left one. Well, the very left one, what we have here is we have a fully conjugated system. Each one of these carbons are sp2 hybridized, and we're cyclical. So we have a possibility of either being aromatic if the pi electrons follow the 4n plus 2 rule, or anti-aromatic if it follows the 4n rule. So if it's aromatic, then it's going to be highly stabilized. If it's anti-aromatic, it's going to be highly unstabilized. So here we see that we actually have 4 pi electrons. So we actually follow the anti-aromatic rule with n being 1. So we have 4 pi electrons, making this anti-aromatic and a very unstable carbocation intermediate, explaining its very minimal reactivity. Here we don't have an aromatic or conjugated system. All we have here is a secondary carbocation, which is more stable than an anti-aromatic compound here. But what's interesting is this structure, because this structure is cyclical. It's fully conjugated. Every single one of these carbons are sp2 hybridized, and it follows Huckel's 4n plus 2 rule with n equaling 1 to equals the 6 pi electrons that we see here. So because of this carbocation can actually delocalize over the entire ring through resonance, and it makes this intermediate highly stabilized. Therefore, it's easily favored and easily goes through SN1 reaction mechanisms.